All right, well, we're a few minutes into the hour, so go ahead and kick us off. Let me go ahead and share the screen first. All right, well, I just wanted to welcome you all here today. Thank you for joining us for our third information session titled, Can I Build Here? My name is Krista Haringa, and I'm the one of the coordinators for the Alaska Tribal Resilience Learning Network. The Alaska Tribal Resilience Learning Network is part of the Alaska Climate Adaptation Science Center, which is one of 8 climate adaptation science centers around the country. Our office is located on the traditional territory of the Lower Tanana Dene people on Trafyada, or Indian Potato Ridge, is where the International Arctic Research Center, where we're located. Just a few Zoom reminders. If you're calling in on the phone, please mute yourself. If you don't have a designated mute button, you can press *6. Everyone who's joining today should have been muted automatically. We hopefully will have some time for question and answers at the end of the session. And so at that time, we'll go ahead and be able to unmute yourself and participate. Just an overview of the Alaska Tribal Resilience Learning Network. One of our overarching goals is to build a community of learning, sharing, and support for Alaska tribes and indigenous communities that are responding to current and future impacts from climate change. There's a few different ways to participate in the learning network. One, of course, is by joining one of these information sessions, but we also have network calls following each information session, which is a chance to talk about some of the specific circumstances, challenges, or lessons learned related to each of the topics that we're covering. We're going to be hosting a network call next Wednesday at the same time at 11 a.m. And that's just it's a space for open dialogue. So definitely want to encourage you to join if you're able and interested. We also have the Tribal Resilience e-bulletin, and that goes out every 3 weeks or so and includes a lot of different information about upcoming events, resources, and also just information about our program. It's just a great way to learn about what's going on in the world of tribal climate adaptation. You can also join our listserv, and that's mostly just to receive notices of upcoming information sessions or network calls that we're going to be hosting. And finally,
I'm sorry, can you advance the slide?
That's all for here.
Oh, I'm sorry. Okay.
Yeah. So you can also join. We have an one-on-one check-in calls, and this is mostly for tribes or organizations that are getting started in their adaptation planning process and want to have a chance to just talk about some of the unique conditions of their planning process. And all this information is on our website. The link to that is on the bottom of this page. And wondering, Molly, if you could go ahead and put a link to our website in the chat. And I want to pass it over to Alexis to do a few brief announcements for us.
Hey, Krista, I'm just, you're still on the first slide of the slideshow. Is it supposed to be advancing down?
Okay, it's advancing on my end, so maybe I'm going to stop sharing. Can you see, what are you seeing now?
Currently nothing.
Currently nothing, okay. Are we on the announcements page?
Yep, now we're on the announcements page.
Okay. Sorry about that. It may not work when I'm sharing from a full screen. All right.
Okay. Well, welcome everyone. So here are just a few announcements. So tomorrow, the Palo Band of Mission Indians Environmental Department will be hosting the second part of an interactive webinar mini-series that'll help tribal serving professionals with the knowledge and skills to address tribal well-being before an emergency hits. And so there'll be this part and then another one in a couple weeks, I believe. And then on May 26th, as Krista mentioned, we'll be hosting this month's Learn Network call that'll kind of continue the conversation that we'll be having today, provide an open space for sharing ideas and asking questions related to this information. And in June, the Affiliated Tribes of Northwest Indians will be hosting 2 events focused on traditional knowledges as part of the National Tribal Leadership Climate Change Summit. The first session on June 8th will be a session for everyone. And so it'll be, focusing on tribal rights and sovereignty and how to apply that traditional knowledge and traditional worldviews into policy and programs. And following the next day on June 9th will be the youth track session. So 16 to 25 is the age range that's expected. And this will kind of focus on traditional knowledges and how to integrate that specifically into youth programs and culture camps. That'll have a great interactive panel discussion with those that are actually running these types of programs. And listed below the events are the registration links. For tomorrow's event, I recommend registering as soon as possible as space is limited. But yeah, that's what's upcoming so far. Thank you.
Thanks a lot, Alexis. And I'm just going to reverse back to this slide and just mention that the Alaska Tribal Resilience Learning Network has a number of different staff and collaborators that are important to supporting this work, including Alexis Wagner, who just presented the announcements and is a BIA Pathways intern working with us. And I'll just want to provide an overview of today's session. And so Melinda is going to go ahead and provide I guess an introduction and framework for some of the unique circumstances and conditions that that folks are facing in relation to housing development within their communities, and really just emphasizing the different levels of leadership that are important to making those decisions. Next, we're going to hear about some of the different land changes that are occurring from pretty rapid permafrost thaw, and how some of these past changes should inform some of the decision making that we have around housing. And lastly, we're going to hear about some of the lessons learned in terms of what type of structures can or shouldn't be built with some of these rapid changes in mind. We initially had hoped to kick the session off hearing from Geraldine Kelly, who is a tribal member and mayor of the city of Quinnipiac. And unfortunately, she had her and her family just experienced a pretty significant family loss. And so she's focused on that right now. Just our thoughts certainly go out to her. She's a valuable member of our working group, the Alaska Tribal Resilience Learning Network working group, and just brings a lot of wisdom and experience into the work that we do here. Next, we're going to hear from Bob Bolton, and he is a permafrost hydrology, works in permafrost hydrology and modeling, and will give us a pretty good overview of what is happening related to permafrost changes here in Alaska. And lastly, we're going to be hearing from Ilya Benek. He's been with the Cold Climate Housing Research Center for the last 12 years and also brings a wealth of experience and knowledge in construction and building and some of the unique conditions that we experience here in Alaska. And especially when I thank you, Ilya, for joining us today. He is with the ground thawing out is at full tilt. So just carving out some time for us today, we definitely really appreciate it. And with that, I would like to turn it over to Melinda, who's going to be helping introduce the session today.
Dogaden, Krista, thank you. Audette, Melinda Chase, Ezra, Kitchen Chag, Kristan, Tribal Liaison, Kowisinek, Alaska Climate Adaptation Science Center, Siyith O'Neill, Godron. I'm happy to be here today. I'm Melinda Chase. I work as the Tribal Liaison. I know many of you who are on, and for those of you who don't know, welcome. And I just want to kick off this session by really highlighting and asking you to take a moment to look at what Buckland is going through. This is a picture and headlines that is telling of our current issues that our communities are facing. And I want to ask you, for those of you who have chat available, and for those of you who might be on the phone, I'm showing a picture, a recent picture that came out on May 13th, an aerial view of the flooding that's happened at Buckland. And so if you have just a few reactions, what strikes you about this photo? What's your reactions to them? If you saw it, if you're seeing it right now, or if you heard about this and saw it a few days ago when it came out in the news, and if you can write that in the chat, just take a few minutes to write your reactions. When you look at this, what do you see? Connie says devastating, definitely. Scary. Overwhelming, says Krista. Scary, says Todd. Any other thoughts? That's much more flooding than what they're used to, says Diane. A long way to high ground. Thank you, Ryan. Most houses on the site were actually above water, and that there was no more ice upriver and tracking it. Thank you, Stacy. It's good to get an update on that. Any other thoughts? Any from you, Jackie? Well, it's definitely true. All those things are evident when you look at this picture. It brings up a lot of emotions. And yes, Jackie brings up the point that better community planning for future site can be a consideration in this. You definitely see that the whole community is impacted at the individual and at the community level. There is very little high ground. And as Stacy said, at the time of this writing of this article, no water had come into any of the houses. However, you know, the roads are cut off, people are using boats, and the community is used to having been flooded. People know that they're a flood-prone area. However, if you look at this, there are multiple issues. And go ahead to the next slide, Krista. And really, you know, one of the things we're focusing on today is what happens when we have impact and compounding impact. So what does Buckland's permafrost look like? And this data was pulled from the SNAP's community permafrost risk tool that shows that Buckland does have a high risk, if you look at the far right, and that they also have abundant massive ice, high susceptibility, and they already have severe existing problems with permafrost. Next slide. So what do we know and what are we experiencing? Most of you who are on the webinar know this because you work in this area, but we are experiencing rapid change, seasonally big impacts like we're seeing with Buckland. Some of them are daily in some of our communities, and they're both individual like permafrost thaw and compounded by other impacts such as flooding. We know that we're going to be experiencing more extreme events, and that we also have a dire need for housing in Alaska, especially in specific regions or the retrofitting of housing. And we know that climate change is currently outpacing adaptation planning. That is actually a key message in the National Climate Assessment 4. We have a statewide threat assessment that says 144 communities are environmentally threatened and that are going to be dealing with permafrost issues. I mean, who knows if that number is going to stay stable at that as we move forward and you see some of the information presented. However, we now have a new administration that has prioritized action on climate and is raising the issues and raising resources. So what does this mean? It really underscores the need to plan forward. That's also a key message to respond holistically. If you look at those issues that picture presents, it presents a holistic view of the community, and that we significantly need to work together on multiple levels. And so that's some of the message that Geraldine specifically wanted to share this last point. So the next slide. So some of her reflections that she wanted to share, and this is by far not all of them, but she really wanted to stress that, you know, our dire need of housing in some of our region is a key factor in how we're responding to housing opportunities, and the lack of options and the lack of resources play a significant factor in how decisions are made. And that really, she wanted to stress that the individual as a homeowner has a role in understanding climate impacts and the future climate impacts in making their decision about their housing, where it's placed at, you know, where lots are at, giving input to local leadership, whether that's at the city or village corporation level, and that local leadership has a role in understanding potential climate impacts as we're looking into the future and planning forward on housing, because they have a decision-making role and responsibility on behalf of the homeowner as well as the community, and to interact with partners like housing authorities and regional Native nonprofits, as well as places like Cold Climate Housing Center, and helping decisions being made there. So those are some of the things she really wanted to stress. And I wish we had her voice here today, but understand that she's not able to join us. I think that some things to really consider. And, next slide. I think it's, I'll turn this over to Bob now.
Great. Thank you very much. Can you hear me okay? Or do I need to speak louder? Thank you very much for inviting me, Melinda and Krista. I really appreciate the opportunity to talk to you. My name is Bob Bolton. I am a research associate professor at the University of Alaska Fairbanks here in the International Arctic Research Center. I call myself a permafrost hydrologist, and I have been working in permafrosted systems, primarily in interior Alaska and the boreal forest, but I've been recently moving more to the northern and western Alaska as part of my research. And I've been doing the permafrost related research for just over 20 years now. Next slide. Oh, and before, I would like to thank and acknowledge the people who helped me with this presentation. Jessica Guerra, Margaret Rudolph, and Vladimir Romanowski have all contributed significantly to this presentation today. And so the thing I want to start out with is just acknowledging that the climate and the landscape is changing, and is changing rapidly. This is a photo from the high Canadian Arctic, where the landscape has degraded significantly over the last handful of years. This is Vladimir Romanowski's group that went out, and just a few years prior to this photo being taken, the landscape was flat and normal. A few hot summers, maybe some snow conditions, and the conditions were ripe. Whatever happened, the landscape changed rapidly and significantly. And we're seeing these types of changes all around the Arctic, including Alaska. And so I just wanted to show a photo of this rapid change. Next slide, please. And so let's just start out with what permafrost is. The definition of permafrost is just ground that remains frozen throughout the year. So it doesn't undergo the seasonal freeze-thaw cycle in the summertime. Usually the definition includes a 2-year period, and that might be at least a 2-year period. It can be a combination of soils, it can be a combination of rocks and ice and water, any combination of that, and the amount of soil and ice and that relationship determines a lot of how much the landscape will change if the permafrost thaws. Permafrost in northern hemisphere occupies about 24% of the ice-free land area. And on the right here, I'm showing a map with Alaska circled in blue of the regions that are permafrosted, with the darker shades of purple being continuous permafrost, and then the lighter shades being more discontinuous or sporadic, and then the yellows are permafrost-free regions. Next slide, please. And so here I'm showing a map from Vladimir Romanowski of all his permafrost monitoring sites, which are shown in red. And then the USGS has a number of Geological Survey has a number of long-term boreholes scattered throughout the state as well. And again, I'm showing different shades of blue on this map. And so the darker shades of blue in the northern Alaska indicate continuous permafrost. And continuous means that the landscape has over 90% permafrosted soils underneath it. And so so there's typically an active layer, which is the seasonal freeze-thaw, which can be up to 1 meter deep. At the further north you go, the more shallow, or 3 feet deep. And then as you move further south, then we go into a discontinuous permafrost, which is where Fairbanks is at. And that landscape is typically 50 to 90% permafrosted. And that tends to occur based upon the aspect or the slope direction of the landscape. And so southern facing hill slopes tend to be permafrost free, while northern shaded slopes tend to have permafrost, and then the colder valley bottoms also are permafrosted. And then as you move further south, then it becomes even less permafrost and warmer permafrost, and more susceptible to degradation and thawing and change. The interesting thing about, or what I think is interesting about the discontinuous permafrost in interior Alaska, where I live and work, primarily is that the permafrost is very, very close to the freeze-thaw point. It's very close to 32 degrees Fahrenheit, and once you shift from a frozen soil and you melt the water that's in the soils and you go to a thawed soil, it's really difficult to go backwards in time unless there's a significant change in the climate. And so we're kind of in interior Alaska, sort of at ground zero for really significant changes in the landscape due to the permafrost degradation. The further north you get, it's colder permafrost and much further away from the freeze-thaw point, but we're still observing significant changes up north. But here in interior Alaska, we're seeing significant changes nearly every year. Next slide, please. And so this is a figure just showing the instrumentation that measures permafrost temperatures. And so we typically have, in the upper left, we are showing a very small micromet station, which typically has a wind direction and wind speed, which we see at the very top. Just that on the lower, below the wind speed anemometer, we see temperature, relative humidity. On the left-hand side of that, we measure snow height, and so snow accumulation, and then the melt, which is a very important factor for permafrost, whether it's stable or unstable. And then a solar panel to heat the data logger, which is shown in the white box. And then inside the white box is the figure just to the right, showing the wiring, and then the tiny little hobo data logger. And so for the near surface, so the 3 meter to 15 meter, which is about 10 to 50 feet depth, they use these wires that are hooked up to the data logger to monitor daily measurements. But then for the deeper permafrost temperatures, so the 60 to 100 feet, and then the 120, which is about 300 plus feet deep, they use these spools that Vladimir's showing here on the upper right photo, where you drop a line down into the borehole, which is the gray tube there, and they measure the temperature going through depth at different points. And so this is the way we measure the permafrost temperatures through time. So the next slide here is I'm showing an example of this. This is in Dead Horse at the northern, near the coast in northern Alaska. And so on the left, on the top axis, I'm showing temperature in Celsius. And so minus 8.5 is close to minus 17 Fahrenheit, and minus 6 is close to 21, or 16 point, so minus 8.5 is close to 17 degrees Fahrenheit, and minus 6 is close to 22 degrees Fahrenheit. And then this, going down the left-hand side of this plot, this is about 65 feet to, at the bottom, 165 feet below the ground surface. And what I'm showing here, so the black dots are 1984, and then each different dots or different string going down are permafrost temperatures at different years. So the black squares are 1984, which is very close to the left-hand edge. And then on the very, very far right-hand edge is 2013, which is the red squares. And so what you can see here is going through time from 1984 to 2013, there is a significant shift in the temperature, moving from colder temperatures to warmer temperatures. Still well below freezing, but significantly changing towards the freezing point. One really important factor about this, or consideration about this plot itself, is that when you're at 65 feet below the ground surface, you're well below the seasonal freeze-thaw cycle that happens every year. So the changes that you're seeing here through time moving forward, getting warmer, can only be attributed to changes in the climate and ecosystem itself, and not a seasonal change, but a long-term fundamental change in the system itself. So going from these cold temperatures to a warmer temperatures. Next slide, please. And so with permafrost, one of the really fundamental things that's critical, especially when you're considering building houses and changes in the landscape, is this idea of the ice that holds the soils together, that's frozen, and when it thaws, then the ice or the water doesn't have any structure or ability to hold anything above it, or even the soil itself, and the soil will collapse upon itself. So what I'm showing here is a number of ice wedges that are located in the permafrost tunnel, just located outside of Fairbanks here. And I'm just going to focus on the middle and the right photos. But what you can see, these ice structures, they're very old and they're massive. And so if you can imagine that if this ice melts and loses its structure, you lose a lot of the ability for the ground to just stay stable and stay in its present condition. I think these photos are quite amazing. The tricky thing about ice and ice wedges is really difficult to detect the amount of ice and the type of ice, whether it's just in the soil pores and between the soil particles, or if it's this massive ice wedges from the air. As you go further north with less vegetation, it becomes a little bit easier with polygons. But as you go into more forested areas, these structures, underground structures, are very, very difficult to detect at a larger scale in terms of planning. Next slide, please. And so here's a schematic of the degradation of these ice wedges on the north slope. So if you start with the ice wedge polygons, low center polygons, which you see frequently on the north slope, you can see that you have these troughs in the underneath the ice wedges and the soils. But as these ice wedges degrade and the soil subsides, then you end up with these high-centered polygon structures, which become much drier over time. In the upper figure where it says organic and mineral, these areas can kind of act like bathtubs. They can be very wet, often with they look like little ponds, or if you walk across them, they'll be quite wet and you'll get wet. But these high-centered polygons can be quite dry as the waters drain off to the troughs, these larger troughs underneath above the ice wedges there. Next slide, please. And so here's an example from Jessica and Margaret showing a core of ice-rich permafrost. It's sort of a before and after. And so you can see that the ice, the white striations in the left-hand figure there, that's ice that's holding the soil column together. And if you allow that soils to thaw and the ice to melt, then you lose all structure of the core itself. And that's what you end up on the right-hand side. You just end up with basically a bunch of mud and water above it. The soils underneath have no structure or ability to support any type of structures. So pretty dramatic change if you allow the soils to thaw. Next slide, please. And so when you start thawing out some of these ice wedges and ice-rich permafrost, you end up with some pretty dramatic changes in the landscape, and they have different consequences for everybody and different living creatures and beings. So here's a headline from the Alaska Dispatch News from a few years ago. The community of Bethel had just started paving their roads, and that disturbance and the change had tipped very warm permafrost, frozen soils into a very unstable permafrost, and it impacts their roads, and you can see the waves in the road. And so each of those dips are where these ice wedges used to be, and now they're starting to thaw. Next slide. There are also societal impacts. You can see the structures of buildings cracking in the upper left. Has a big impacts on pipelines. This is a warm pipeline that thawed the ground around it and caused dramatic changes. Again, another pipeline on the left, and then buildings collapsing due to the change in permafrost on the right. And then the photo on the upper right-hand corner is the parking lot behind IARC, the building that I sit in. And every year we seem to be having these sinkholes that are appearing right at the edge of the parking lot and the forested area where the soils have been disturbed. But you can see that there's a big gap where the ice is melted and it's leaving a big void underneath. And so it's can be quite dangerous and dramatic. Next slide, please. Here's another societal impact. So this is on the Hall Road going north of Fairbanks. A few years ago, there was some massive flooding, and you can see that the impact of water eroded the ice wedges. And so where the truck is to the north, to the going up the figure there, you can see where the ice wedges were located, and the road going across has been washed out and degraded because of the combination of the flooding, but also because the permafrost had just collapsed underneath it as well. So another dramatic impact. The figure on the lower right is Farmers Loop Road, just adjacent to the university. This is before they rebuilt it a number of years ago. And this site was pretty interesting before they rebuilt this road. The strategy was to just add another layer of asphalt, and then it would collapse. They'd add another layer of asphalt. The pavement would split open, and things would happen. And so when they finally repaired the road properly, they dug up many, many feet, over 10 feet of asphalt that had just been laid down year after year after year. And they finally dug out all the permafrost and all the bad soils and added more appropriate soils and repaved, and the road seems to be in much better shape now. You can also see that the light posts are tilted, and that's also due to the permafrost degradation. It becomes a more unstable and potentially dangerous situation there. Next slide, please. There's some landscape changes that occur with the permafrost that I showed at the very beginning. You know, dramatic changes in on the North Slope or in high Arctic Canada. But here's some photos just outside of Fairbanks. One showing Drunken Forest, where the trees are tilting over just due to the ice wedges. So the ice wedge used to be, sorry, Melinda, yeah. You can see the ice wedge right below this big birch tree where it's subsiding, and so this could impact trails or pathways. And then the power of water also has the ability to erode the landscape in these ice-rich soils. And so this is a thermal erosion photo taken just adjacent to the Poker Flats rocket range north of Fairbanks near Chattanooga. And this was just caused by a little bit of disturbance from a four-wheeler track. A little bit of water flowed downhill, but that water has, and the power of water to erode and maintain heat really devastated the ice-rich permafrost soils underneath the soils there, underneath the surface. Next slide, please. The changes in the land surface can also have dramatic changes on wildlife habitat. And so here's an example of going from the low center polygons on the left and having the troughs, the ice wedges degrade, and you end up with a high center polygon. You also end up with different habitats for different bird species. And so this is pretty common. The birds are dramatically impacted, but also foraging sites for larger animals can also be impacted by changes in the permafrost itself and the migration patterns itself. Next slide, please. And so I just want to show one photo of, or one slide of modeling work that's being done at the Geophysical Institute here at the University of Alaska Fairbanks. This is showing on the left-hand side permafrost temperature in, oh, if I got these backwards. On the right side, it's from, let me see here. Yeah, ground temperatures. So the left-hand side, the darker colors, the darker blues are colder temperatures. And then, so this is at the beginning of this last century, so 2000 to 2009. And then on the right-hand side, we see warmer colors, the reds, and then much less blue at the end of the century, 2090 to 2099 simulated. And what the Geophysical Institute is projecting with their modeling activities that there's much less permafrost, and the communities of Point Hope and Kivalina will lose all of their permafrost by 2100. And so the changes that I showed earlier with the changes in the permafrost, the deeper permafrost, we're expecting these changes to continue well into the future. And with that, I'll stop and we'll pass it on. And thank you.
All right, thank you, Bob. And with that, we'll go ahead and turn it over to Ilya.
Good morning, guys. I will see if I can get the video to work. Let me know if there's an issue and we'll turn it off again. Sometimes we have spotty reception. And I'll start by defining my role at CCHRC. I'm a carpenter by trade. And so as such, working for CCHRC, I have traveled pretty much all over the state. And I am by far not the only one that travels to rural communities. And one thing that we all do and ask of each other when we go travel is to take pictures of the structures and see what seems to be working, see what isn't working, and try to figure out, you know, what the failure points are. And so what I'm going to try to present is a sort of a mile-high view on some of the things we've noticed and ways that we too have started looking at things differently and looking forward and how to build better structures that can help withstand ground movement. And this is the big picture. And you know, what is the thawing permafrost doing to houses now? And when we build more houses in the future on unstable soils or potentially unstable soils, how do we build for it? Next slide, please. I was going to show a couple of slides that sort of illustrate also what we're seeing with our climate change and warming trends. This here shows the pronounced, oh, sorry, a little fast there. This shows the pronounced temperature difference in Alaska since 1970. And especially when you look at interior Alaska and Western Alaska, where we have comparatively warm soils temperatures, this increase in Fahrenheit is getting us dangerously close to warming, or it's already warming, which is why we are seeing some of these dramatic failures. Next slide, please. The other map here shows how much more water we are now faced with versus what we had in the 70s. And when you look at Western Alaska again, and also moving up to the slope, I mean, a 20% increase in water is a tremendous volume. And water is permafrost's biggest enemy in terms of how quickly it can erode permafrost. And I look at that in terms of foundations. If water gets under those foundations, the failure rate as a general rule increases dramatically. Next slide, please. So that's the question. What does all this mean for housing? And I have a series of pictures that talk about starting with the soils and the siting, and then some of the problems and some of the ways to deal with it. This slide looks very familiar, Bob, I'm sure. I actually live on this type of ground, and my personal property where my house is had a soils boring just like this, and it's unsettling to say the least. Right now, my ground is still frozen, and so I am on the left, and I am considering all kinds of experiments right now to try to keep it from reaching that point on the right side. Once you start to thaw and you've pretty much lost it. It's a very difficult process, if not impossible, to stop, especially economically. So another thing to think about is how to keep that ground frozen with site shading, roof overhangs, gutters, and so forth. Next slide, please. Here's sort of a broad spread of the types of soils we generally work with in Alaska. And the point I want to make here is some of these soils can be frozen, especially those on the left side of this graph, the bedrock, the gravel, the coarse sands, and to some extent the fine sands. They can be frozen, but still have great bearing capacity. They won't be as affected if there's ground thaw. But unfortunately for us, those three on the right, the clay, the silt, and the organic material are some of the most prevalent soils in Alaska. And those soils like to hold water, and in turn that freezes and becomes ice, and you get these ice-rich soils that are extremely vulnerable to thawing. And all is not lost. I would say when you're looking at siting or looking at locations to move housing, give preference to the four on the left. And there's plenty of soils engineers and structural engineers out there that can help interpret what a site is doing and how to optimize your house location. Next slide, please. This is soil sampling taken in Fairbanks. This site at the top of it looked relatively normal. It had large deciduous trees and conifers, spruce and birch, and go down about 20 feet, and all of a sudden we got into massive ice. And the surest way to know what's under that ground is to drill it. And for residential structures, that doesn't always make economic sense to do, but many of our communities have a history of some soils borings in the area. A lot of times it's higher dollar infrastructure. You've got washaterias, you've got schools, you've got wastewater systems that in some cases may be buried underground. So in those situations, if you can find those old soils borings, a lot can be gained. And we typically try to look at that soils boring history for a community to determine what a site might be doing and what's under there. Next slide, please. And this just kind of underscores build to suit the conditions. And so the site, I think a lot of times historically we've been very casual with how we build on a site. We'll push some gravel over it, and we won't really pay attention to what the water's doing on the site, or really what the ground is like. And we can't really afford to do that anymore. And I have a case study I wanted to share with you guys, and that's next slide, please. So this is Nelson Island. This is a current village relocation. Many of you are likely familiar with it already. This is the new site of Murtarvik, and it's the old village of Newtok. As quickly as they can, are moving from nearby to Nelson Island, and this is the beginnings of that village reconstruction. This is very much a tundra landscape, and there's a layer of organic material on this island, but it is also extremely fortunate that this island actually is an old volcano and is underlain with bedrock. And so this is a unicorn in many cases for Western Alaska, but this is in many ways your perfect scenario as having stable soils underneath. And so there is an active layer, and that active layer does contain permafrost, but not too far below that active layer is solid rock. Next slide, please. Here's one of the quarries on the island used to build an airstrip and put in roads. It shows how close that rock is to the surface and how much of it there is. This is a really good blessing if you have access to this kind of material. Next slide, please. And so this is a classic approach. And when you have gravel, you have a source of rock and you can crush it, this is generally how we build. We will import that gravel from the quarry to the sites and build raised pads that drain well and that are, capable of supporting house foundations. On the other hand, depending on the grade and the site conditions, it takes a lot of gravel, and that equates to a lot of work and money to build up these pads. And one thing I think worth considering when looking at a reconstruction is to evaluate all options very thoroughly. I think this is an excellent way to build. In this case, however, though, I think some other considerations would be very worthwhile. And this is something we at the Research Center have been very curious about with Nelson Island in particular. Next slide, please. If bedrock is so close, an economic analysis of the cost of driving pilings would be very interesting. And in that, if bedrock is anywhere from 10 feet to 50 feet down, if we can drive steel casings down to that bedrock, we now have a foundation that will never move. As long as it is securely anchored to the bedrock, it is possible to get 100 years out of it if you can manage your drainage conditions around the site. And so we should be looking, I think, at economic feasibility studies that if there is good ground underneath there, and we take into account how long we want our houses to last and what it will cost to maintain them if we don't use that good ground, we need to make that decision. Is it better to drive piles, or is it better to import gravel pads? Next slide, please. This is a series of common problems that we see all over Alaska where we have unstable soils, and also some solutions as to how to deal with those problems. Next slide, please. Here's a new house under construction, a duplex. And you can see the large puddle. The rains can be quite telling, especially when they're heavy. And there's obviously a low spot on this site. Fortunately, this can be repaired. Next picture, please. And this is site maintenance. It doesn't end when the house is built and everybody walks away. The ground will continue to move. Those puddles will continue to show up randomly as the ground subsides. And it's really critical for long-term building durability to keep those puddles away. And I think that's sometimes where we fail, is we see the puddle, but we don't act on it. And eventually it works its way under the foundation. And then that thaw process starts, where it's really, really critical. And it's very hard to stop and very expensive. So site grading is a maintenance issue that should be an ongoing understanding that we need to watch this, maintain it, keep an eye on what the water is doing. Next slide, please. Bob showed you guys a picture of a road doing exactly this. And it's also doing this to other high dollar infrastructure. This is a sewage system, wastewater system, and these are extremely expensive systems to install and maintain in rural communities. And at a greater and greater rate, you're seeing ground subsidence affecting these systems. And in many cases, it may become impossible to maintain these systems economically moving forward. Next slide, please. Here's an illustration where one of these systems connects to a house. It's a very rigid connection point. The house is doing one thing, the waistline connection is doing another thing, and you can have separation problems that can occur actually quite quickly. So that box attached to that wall is a very common way of attaching these types of systems. And once again, more and more, we would expect to see failures at this junction point. Next slide, please. One solution to this problem is to go small. And this is a wastewater treatment plant. This particular version is designed and built here in Fairbanks. It's been in use about 20 years. This particular plant right here is serving a house up in Anaktuvik Pass, so they can work in very cold climates. But if you start looking at a system like this for viability, all of a sudden the high dollar infrastructure cost of running waste lines to houses goes away. And so I think moving forward, we should consider everything we can to serve that house on that site as a pod versus trying to connect all of our houses to an octopus of waste lines and water lines. Next slide, please. This is a pretty typical picture of many of the houses that we actually work on, and we try to repair sometimes or try to design repairs for. You can see the staircases and the porches are bearing separately. They are moving independently of the house, and the house itself has lots of bearing points under it. That makes it very difficult to adjust if one area starts to drop away. Next slide, please. Another design issue we see is a tendency to want to add many other structures to the house. Your simplest, strongest shape tends to be a box, and it may not be attractive, but from a structural standpoint, it sure works if you utilize it properly and can put a strong foundation under it. In this particular case, you've got posts supporting the entryway, both entryways, and over time, and you can sort of see in the picture, that front entryway at the bottom is starting to separate away from the rest of the house. And if you don't maintain that, it is almost impossible to put that entryway back in. Once those nails and connection points separate, that's pretty much it. You're looking at major work to repair that. So the lesson is keep it simple as much as you can. Next slide, please. Here's a duplex in Bethel, and more frequently now we are working with steel beams instead of wooden beams. And this is I think a mindset we see more in residential construction, and that is that as residential carpenters, we always reach for wood first, and you see steel more in commercial work. But pricing out steel and wood, they're actually generally pretty close in price. And what steel lets you do is build continuous foundations. This structure here is about 80 feet long. It's a duplex for housing, and it's supported only on 2 beams at the outsides. And after 3 years, this structure was moved from its location by being put on large axles and being towed by a loader. So it was moved to another location in Bethel, and it held up because that foundation was strong enough to withstand that movement. Next slide, please. Here's another continuous foundation on steel. In this case, you can see there's a main beam supporting the house. There's 2 of those where that one dotted line is to the left, but there are cross beams supporting that deck. And so the deck is part of the house. It's not just attached to the house and supported by separate posts. It actually moves with the house as a unit. And these types of changes are generally pretty inexpensive to make. It just means that when we design looking forward, we need to take into account what all is going to be a maintenance problem if we don't build for it. Next slide, please. This is a classic issue where the stairs are attached and the stairs move independently of the house. You can see already that there's been a repair made to level the house, and the stairs have been replaced, rebuilt, and nailed right back into the same place the old stairs were. This is pretty much a guaranteed failure when you look at that circle on the left where you can see that block in there. This isn't going to stop moving, and this problem will happen again and again unless you can find some way to allow those stairs to move. Next slide, please. Here's a hinge. It's not our design. We actually saw this in several rural communities in Alaska. I don't know who to give credit to for the hinge, but it's a simple and yet elegant solution to allow these stairs to move independently. We can get 6 inches to almost a foot of movement out of the ground, depending on how we adjust that hinge before it becomes a problem. So the stairs are the only structural attachment to that house. The deck on the left is cantilevered out. It is part of the house. And the stairs just hinge seasonally. So as that ground moves seasonally, or if that house moves over time, the stairs can withstand quite a bit of stress before you have to repair them. And you have a lot more warning. You can look at your stairs and see that they no longer look square to the house, and it might be time to adjust the pad that the stairs are resting on. Next slide, please. This is something that we are seeing more and more too. It's not leveling the house quickly enough and letting it go. And if you get to this point, the houses can be a total loss because now water has entered the wooden part of the structure. And I'm actually going to be fixing a house just like this weekend in Fairbanks. And one of the things we're seeing with climate change is that these types of settling can happen incredibly rapidly. The house I am working on dropped almost a foot in 3 years because that site had heavy rains. It had no gutters, just like this house. And all that rainwater and snow melt slid right off of the roof and then landed on the tundra and wicked its way under the house. And now there is standing water under that house, and the house is in contact with the tundra. When you get to this point, fixing it is incredibly difficult because you can't use the simplified hydraulic bottle jacks and steel plates that we normally would. Now you're looking at more complicated airbag systems, heavy machinery, and a variety of brackets and such that may or may not work. And so the message here is catch it early. If it looks like it's moving, start dealing with it soon. Next slide, please. Here, this is a situation where water was allowed to reach the foundation. This didn't happen right away, but it wasn't dealt with right away. And especially in maritime climates and coastal climates, when these timbers get wet, they're extremely slow in drying out. And so that rot process can move pretty quickly. And so if you see foundation timbers getting exposed to water, in contact with water, that's a dire situation, and it can make or break a house. Next slide, please. This is a maintenance issue, and gutters are one of our best friends in keeping water away from the house, but they do require maintenance. And here you can see that the downspout ends right over the pad. And so all the snow melt and rainwater that comes off that roof comes to this collection point and runs right down to the place where you would least want it. And so, you know, as you are walking by, people should, as they're walking by, should be taking a look at these conditions, and a simple fix, you know, is to add a downspout, and it can save a lot of headache in the future. Next slide, please. This kind of underscores keeping it simple. If we can move all of our bearing points on our structures to the outside walls and we eliminate center beams in houses, they are more likely to get maintained. And this is human nature, I think. We have all of this in us that we walk past the house, it looks good on the exterior, and we don't think of what's going on in the center. And by the time we notice a hump in the floor and something's going on in the center, it may be very difficult to try to fix it. You can see there's a spruce log to the right side here that, you know, there has been some desperate attempts made to keep this floor level. And it's not too late to fix it, but it's out of sight and out of mind. So looking forward, we should design for structures that are easy to level. Next slide, please. Here are some best practices. You can see on the right, the gutter system is now complete, and the downspout has a kick out that takes that water away from the foundation out to the edge of the pad. The columns supporting the steel beams are easy to access. The cribbing is easy to access. It's all in plain sight. And so these are all strategies that allow us to catch problems and maintain the house before things get out of hand. Excuse me. Next slide, please. So this, unfortunately, is becoming our new reality. And this is a question we are going to continue to be faced with, is what do we do? I mean, at some point, some sites no longer will be viable for construction, or we may see that there is some time, but ultimately that ground may fail. And at this point, we might be considering how to move houses. Next slide, please. I don't actually know where this slide came from, but I like it for its clarity, where you can see the entire steel foundation, pipe foundation underneath is one rigid structure. And it has a cross pipe in the front there, so you can hook a bulldozer to it and drag it away. And it's also small and fairly simple, so it can withstand the stresses of being moved. And I think that this is a trend that we should start looking at. Build small and build it so it can be moved in your worst case conditions. Here's a next slide, please. Here's a foundation that we worked with a Canadian company, Triadetic, in Murtarvik. And at the time this house was built, the site didn't exist yet. And so we built this house in a temporary spot out on the tundra on landing mats. However, the foundation structure underneath is extremely rigid and comes with a set of 3 skis so that it can be towed. Next slide, please. And here you can see the house on its temporary site, and construction is underway. Next slide, please. Here you see the house is finished. In this case, it's a little bit hard to see, but there's a steel cable, and the excavator bucket is connected to that cable, and the cable is hooked to the skis. And so they were able to skid this house a long distance. I want to say it was about a quarter of a mile over the tundra. It wasn't winter, obviously, and move the house. Next slide, please. And here's the house. Now that the pads are in, the house is set securely on the site. And a system like this can cost a little bit more. We are working in a community right now where that is about, I don't want to say prices necessarily, but it's maybe in the $20,000 to $30,000 range, closer to 30 when you add the skis. But what that extra cost gives you is the ability to move if things really start to go. And that's an economic study we should consider, is what happens if we have to move the house and we have no way to move it, no good way to move it. What is the end result? What's that cost? Can we afford to pay a little more up front to design mobility in the houses, and then choose building components that allow us to move the house? Next slide, please. If you have any questions, I'd be glad to try to answer questions. And I realize next week, it sounds like we also have a question and answer session. So I'd be very much be looking forward to that. And thanks for listening, guys.
All right. Well, thank you, Ilya, and thank you, Bob, and also Melinda for the introduction. Do you want to apologize for going a little bit over, but as Ilya just mentioned, we will have a chance to have more conversation and dialogue around some of these topics next week. That's just on an audio conference call, and it will be Wednesday at 11. We have information on that posted on our website. But if it's okay for folks, if there are any questions for Ilya or Bob before we sign off that you want to direct towards them, please do. I know that we're over, so if you have to get going, definitely understandable. So with that, I'll just open it up for questions. All right. Well, if hearing none and also seeing none in the chat, again, just want to encourage folks to join our conversation next week. I think Ilya should be able to join us, and maybe potentially Bob. And hope you all have a great week. Thank you.
Thank you all.
Thank you.
Thanks, guys.
Thank you. Well, have a great day.